Welcome to 10 minutes CS. 1963 minimum number of swaps to make the string balanced. We given 0 index string S of even length n and string consists of exactly half open brackets and half closing brackets. That means that the string will be jumbled, let's say in this way, but after swapping we can always reach to a condition such that the parentheses are valid parentheses. So we don't need to check for the case when uh, the solution can't be reached. A string is called balanced only if it's an empty string or it's in AB such that A and B are balanced strings, such as like this, or a C, let's say we take it as C and it is within closing brackets. So it is considered as balanced string. We need to swap the brackets at any two indices any number of times, and we have to return minimum number of swaps to make the S balanced. So let's go through this example. We have this as a string. We can swap the 0, 1, 2, 3. We can swap 0 and third index, and once we are done with it, we will reach this S string, which is a valid string. Similarly, for this one, let's say we have 3 closing, after that we have 3 opening brackets. Now minimum number of swaps that we can do here is, let's say 0, 1, 2, 3, 4, 5. We can swap the string at the character at 0 and 4th, that means this one and this one. So we will have something like this after this, and after this we can swap this and this, so we can get this. So this is also valid. So number of swaps needed was 2, and this is already a valid string, so we don't need any swaps, so we will just return 0 here. Now let's do some observations to understand it better. Let's say we are given a string as this. In this scenario, it is already a valid string, so we don't need any operation, so the answer will be 0. So how will we know whether it's valid? We can take a stack, and in it we can iterate over the string, and for each index we can check if the character is equal to closing. We can add it to our stack, and for each character, for this we will push, and if our character is this, so we can pop it. So we reached here and we added, then we see that it's closing brackets, that means it can be popped, so we popped it. And after this we reached here, we again added it, and then again we reached here and we pop it. And once that is done, we do not see any closing or any opening brackets left, so it is 0. Or we can have a variable as mismatched, which will be 0 initially, and we can just iterate over it, and for each time when will we have a mismatch. So let's think of it. Let's say we have something like this. So when we tried to add it to our stack, we reached here, so it's a closing bracket, but we need to pop, right, whenever we reach a closing bracket, but this time our stack is empty, so that means we haven't seen any opening bracket till now, so there was no matching opening bracket for this closing bracket. In this case, we should increase the mismatched count. So if our stack is not empty, if our stack is not not empty. In this case we should pop it, else we should increase our mismatched counter. So we see that it is empty, so we increased it to 1, and after this we reached here, it's a closing bracket, so we added it. So after doing this, we how many mismatched string we have? So this is 1. That means there was one pair which was mismatched. So how many swaps are needed for a pair to to uh, to be a valid pair after swapping? So this is a mismatched pair. We can swap it once to make it a valid pair. What if we had something like this? Instead of one pair, we had two mismatched pairs. So we will again iterate over it, and for each closing one we don't see any the stack is empty, so our mismatch count will increase from 0 to 1, then it will reach here, it will become 2, and for this it will just keep on adding. So we have 2. And how can we make it valid? We can swap these two to make it a valid pair. So for mismatched 2 also we had same number of we just need one swap, and for one mismatched also, how many mismatched we have? We had here where we had 1, and here we had 2, so swaps needed was 1 here also. What if we had 3? So in this case, how many swaps we need? We just did this here. We can swap it from this ones, so it will be like this, and then we can swap these ones, so we will have this. So number of swaps needed is 2 for mismatched swaps are 2, for mismatched 3. So let's say we have 4 mismatched pairs. In this case we already know the answer for this one, right? We can swap these to make it valid, and similarly we can swap them also to make it valid. So number of swaps needed will be 2, for mismatched 4. And later on, if you will just keep on doing the same thing, you will see that the swap needed 3 for 5 and 3 for 6 also. So what does it indicates here? So the mismatched count and swap count. So for every mismatch, let's say 1 we need 1, for 2 also we need 1, for 3 we need 2, for 4 we need 2, 5 2 3, and 6 we need 3. So if it's an even number, we can just divide by 2, so we will get the answer. And for every odd, we have to add 1 to it. So it's same as if mismatched is even, then divide by 2 will be our swap count needed, and if it's odd, so swap count needed will be m plus 1 divided by 2. This can be written in simpler ways as m plus 1 by 2, and we take floor value of it. So anyways, let's say we had 2 here, so 2 plus 1 divided by 2 will be 3 divided by 2, which is 1.5. And if you don't convert it to double or anything, this will give us 1 only. So that's how you can do it. Now let's look at the code for it. We will code this same stuff in Java. So initially we have the length of our string, we have our stack, and the mismatch count is 0 here. We iterate over the string, we take the ith character. If it's an opening bracket, we keep on adding it to the stack, and then we will check if the stack is not empty. That means we can pop it and it can form a valid pair of parentheses. That means we don't need to add it to our mismatch count. Otherwise, if it's a case of like this, so we reach here but we don't have anything to match with our closing bracket, that means it's a mismatch. So we increase the mismatch count, and finally we just return the mismatched plus 1 divided by 2. The time complexity for this approach will be big O of n, as we are iterating over the string s, where n is the length of the string, and the space complexity will also be big O of n. Ideally it will be big O of n by 2, which is approximately equal to big O of n, because we will be adding only the opening brackets which are given in the problem statement itself, that it will be n by 2. Can we optimize this space complexity? Do we actually need a stack here? What are we using the stack for? We are just using it to check if the stack is empty. That means we had already encountered a opening bracket before encountering a closing bracket. So instead of using a stack, here, we can use just a variable such as int stack size, and it will be 0. Whenever we encounter a opening bracket, we can increase the stack size value, and whenever we are popping it, we can just decrease the stack size value. And to check whether the stack is empty or not, we can check if the stack size is greater than 0. So this way we don't need a stack, so we have optimized our space complexity to big O of 1, as we are just using a variable here. Thank you for watching.